Good afternoon, everyone, and welcome to today's panel discussion on edge computing for AI. My name is Vijay Mistry. I'm a partner at Vipa Digital. We're an advisory and consulting practice in the industry. I guess we're at a fascinating inflection point where AI is no longer confined to just hyperscale data centers. It's also moving to the edge, closer to the devices, closest to the data, and closer to the decision points. This shift has the power to radically reduce latency, enable real-time insights, and transform everything from smart cities to autonomous systems. But with that opportunity comes complexity. Architecture trade-offs, deployment challenges, evolving hardware demands, and questions about security, scale, and return on investment. Today, we're joined by an incredible panel of experts who are not only thinking about these issues, but are actively building the future of edge-enabled AI. So we're going to explore what's working, what the challenges are, and what's next. I'd like the panelists to introduce themselves and give a little background, please.
Thank you. I'm Alexander Bechrakis, Managing Director of Digital Realty in Greece. That includes our Athens and Crete assets. And I'm happy to share any insights we may have with the audience and our friends here.
I'm Michalis Kasimiotis, Managing Director of Hewlett-Packard Enterprise for Greece and Cyprus.
Hello, I'm Christos Rizos. I'm Chief Technology Officer for Intracom Telecom in Greece.
Welcome, gentlemen. Okay, so let's start off. So, Alexandros, maybe I'll start with you. So, how does the convergence of edge computing and AI redefine the sort of traditional centralized compute model or cloud computing model?
Thank you. I think we are in the middle of another paradigm shift where traditional architectures need to evolve in order to meet the new kind of needs of end users, devices, applications. The new ecosystems that are to serve these new, let's say, applications and customers at the end require more flexible architectures. I mean, ideally, if you think back, everybody that's having an application, what would be ideal for them? To have everything centrally in one, maybe 2, 3 locations, and serve all the world. This cannot happen. This cannot happen for resiliency, this cannot happen for latency, this cannot happen at the end for user experience. What was the answer? If you go back 10 years, you saw every, let's say, application provider, that includes the cloud providers, going closer to the users by going to the flat markets more, and then to tier 2 markets and tier 3 markets. And now what we are seeing is another step where even smaller edge sites are created to take this architecture even further closer to the user. So you end up with architectures that if they are flexible enough, they can service part of the application stack from very close to the user, maybe some things in the device, maybe some things in the antenna that the device is served by, then maybe a smaller data center in the region, the city, connected to some regional, connected to some center. So all this architecture creates, of course, additional complexity for the infrastructure, but at the end, it's a new environment that we all try to serve, and I'll be happy to talk more about how we do it later in the discussion.
Michalis, do you agree, or what's your view on?
I agree, and I will just, let's say, put some additional thoughts on top of what Alexandros already mentioned. First of all, let's agree that AI and cloud are, let's say, two, terms that should go together, because you cannot deploy effectively AI, applications without having a kind of cloud modeling behind. Otherwise, it's not, let's say, effective. It's not practical. So the big question is how you can, let's say, take the benefits of cloud close to the points where data is created, so close to the edge. So the one of the questions, because it's not the only question, one of the questions is, can I have, let's say, cloud on the edge point? And the answer, of course, is yes, you can. Cloud does not mean only, let's say, public cloud, hyperscalers, and all these absolutely necessary tools that we all use consciously or unconsciously every day. But it also means that we can also have this kind of cloud experience everywhere. So we have models. We as a company, for example, we have such a model in our effort to create an effective hybrid cloud engine that will support AI wherever is needed. Because, as Alexandros already mentioned, getting closer to the data means that you can, let's say, come more effectively and in a faster way close to the insights that this data may return. You can do it by lowering the cost, and you can, let's say, sometimes do it also with better, let's say, with more secure and with a kind of data sovereignty, better data sovereignty. So here it's not a question, do we need a public cloud versus edge cloud? We need both, is the answer. I think that this is the balanced approach that we should follow.
Okay. Chris, any comments?
Yes, first of all, I agree with both of you. Of course, how could I not? Trying to give a visual aspect to this problem. For me, the traditional cloud is like the the big party that everybody wants to go. It's far away in the city, so you have to face a traffic jam. When you go there, like a big festival, music festival, you will find a lot of people. You will have to face a traffic jam. If you want to find a drink, it will be a little bit difficult to find something customized. While the edge cloud with AI capabilities is like the party next door, like your block party. So what is the benefit? You don't have to face any data traffic jams, no traffic jams. It's easier to do whatever you want, and so you don't have latency, you don't have all these facts. So yes, it is the answer, and I think that we as a company, we are a technology company, we're focused a lot on sustainability at the edge and performance at the edge, so we have many use cases to share that are really exciting. And I think that the edge is not something to discuss about the future, it's here and now. You cannot really do AI cost effectively without doing it at the edge on a proper way.
Actually, sort of following on from that, I do like your analogy there as well. So let's talk a little bit about some of the foundational hurdles. As edge AI deployments scale, what are the most significant technical challenges you're seeing? So, Michalis, let's start with you on that.
I will start with the hardware limitations. Talking about, let's say, public cloud infrastructure, we know that the hyperscaler will already have, let's say, set everything in place, but this means, let's say, huge investments so that they can be utilized by many millions of users. So when it comes to edge cloud, you have either, let's say, to have models that may operate in a similar way, so a significant investment that can be utilized in a kind of cloud experience, in a multi-tenancy logic with many customers. And this could be, for example, the example of a service provider that offers this service, but closer to the data or to the users. If we come to, let's say, to a bigger granularity, I would say that it also comes to the special hardware that may be required, either at device level or, let's say, at infrastructure level, in a bigger scale. And we see that manufacturers produce specialized, special workloads hardware that is able to analyze and, to some extent, act as a kind of local data center, even a device level. So I think that this is the trend. And a third, let's say, point of consideration is the models optimization. So when we talk about AI, we usually talk about, let's say, large language models, for example. But when coming to the edge and our ability to process data locally, we may need a kind of small language models that we see, and then so lightweighting, let's say, the models story is an additional aspect that we should take into consideration.
Alexander, I was just going to say, digital realty, are you making any changes, so as you think about AI at the edge in your co-location facilities?
We're making changes all the time. Any company that wishes to remain on the forefront on its industry has to make changes, adapt, adjust all the time. And we do that. We do have many AI-ready assets, data centers across the world. And of course, we have the ability to modify existing ones as needed. But going back, the important thing is to first understand what you need to do. And as you may have seen from our CTO's presentation, we are closely monitoring all the developments in liquid cooling regarding chip cooling, direct cooling, and everything else. So we are ready to support even the next generation of GPUs. We are also working with vendors, and the HP is one of our favorite ones, to understand how they implement also the technology and how we can work with them to support their systems, because we are a little lower on the pyramid. So we enable them, they enable applications enable productivity and competitiveness of people.
Are you working more closely with their hardware, like the compute manufacturers as well?
Yes, this is what I was saying. We saw some more, like our friends here, to understand not only their current generation, but what is coming. So we are ready from a cooling and powering perspective to support their infrastructure. We don't provide the servers. We provide the place that they put the servers, we power the servers, we cool the servers. Now, all these things though, it's either AI, when we are talking especially AI, inference, etc., when we are talking to the user, or edge, even more the combination, is close to our heart because it goes to our main, let's say, objective. And the main problem we are solving is we provide hybrid data centers that are meeting places between connectivity, compute, ecosystems from companies that provide their own added value services. So the whole thing, the whole marketplace and meeting place inside our data center campuses can create additional value to the people that use them. And the people that use them obviously are the ones that we host, but mainly, we need to always keep the mind of the customer, is mainly our customers.
Chris?
Yeah. So I think that for us, we see the traditional cloud as necessity because it's like the brain for everything that needs to be done. But the edge is like the reflex. So it is local, it needs to be very fast, but it needs to be very intelligent. So with this in mind, you have to always remember that at the edge, you don't have all the resources that you have when you're, using a centralized cloud. So for example, if you are trying to put at the edge a big language model, a language model has many variants. So it can be like 7 billion with limited capabilities, or 1 trillion parameters, which is really large. So if you're trying to get a big model and put it at the edge, it's like trying to get a grand piano, and fit it inside the Fiat 500. It doesn't fit. Okay.
Maybe an Abarth.
In maybe an hour. Yeah. So you need to adjust. So you need to do clever things in order to work at the edge. So you have the centralized cloud that are used to train your models, because we're talking about AI. So we have two phases. So training is something like development. In the classical world, you need to train your models. This needs a lot of resources. This is logical to do it at the centralized cloud. But when you deploy your applications, and this is called inference in the AI jargon, there you want to go down at the edge. So you need to be very efficient. For example, if you're doing like agentic AI, which is the future or the present now, agentic AI can be very inefficient because in reality you have a number of AI models working together. So instead of having just one, consuming power and resources, you have many. And you have like the boss of the agents that is, saying, you agent, you now do this, and then he gets the result. You agent are the perfect next step. You do this and you do this. So this is really inefficient. So in order to make it work at the edge, you need to be clever. So we are going like back to the roots. So we are, decreasing the use of AI as much as we can. So use the big LLM models only where they are needed. And if they are not needed, we can just query a database, which is super fast, and keep the use of the generative AI only for where it's needed. Okay, that's one part. And the second part is, of course, sustainability. Everybody likes AI, but if you are using, ChatGPT to ask something for your cat, you need to be aware that it consumes a lot of energy just to answer this simple, not say stupid because I like cats, but this simple question. So sustainability is a big issue. We are pioneering in this one, and we have an excellent solution that does at the data center and at the edge at the hardware level what you do at the software level. So at the cloud, normal cloud, you have elastic software. So the more resources you need, automatically they are given. So when you don't need them, they are taken back. But the hardware is always on, consuming power. So we have developed a solution that works at centralized cloud, but at the edge as well. What it does, it empties the workloads and switches off the servers that are not needed. And this is a real way to minimize energy consumption. So you need to be clever, make lightweight applications and minimize your energy consumption.
That's great. So let's, Chris, sticking with you, that's great insights. Let's bring it to life. Do you have any specific use cases where edge AI has meaningfully sort of reduced latency, enhanced real-time performance, and sort of really made a sort of changed the game? Do you have any examples?
Yes. So we are focused on the telco industry. So Intracom Telecom focuses on many industries. Our DNA is the telco. We're called Intracom Telecom. We are also, of course, focused on energy and utilities, financial institutions, media and entertainment, but telco is our DNA. So we developed two very nice use cases for the edge at the telco. So what we have in the telco networks, in these new networks, the 5G networks, they are cloud native. So they are similar to cloud. They use cloud technologies, but at the edge. So when you have like a 4G network, an old one, you would have like a cell that covers a really big area. In the 5G network, the cells are smaller in order to give you this high bandwidth and small latency. So by having all these small cells, that means that you have a lot of equipment at the edge that consumes power. Okay, and also in order to make sure that this equipment can handle this traffic, usually it is over-engineered. So the telco operators, they go and put big servers to make sure that they don't lose customers, because if you have dropped traffic, then the experience is bad and you lose customers. So we are using Edge AI. We are putting, fast agents at the edge that are doing something in real time. And this real time cannot happen at the cloud, at the centralized cloud, because you have all this latency back and forth. You need to do it locally. So what we are doing locally, we predict for the next time window of 4 to 5 seconds the traffic of the network, and based on that, we act on the server and we minimize the clocking frequency of the CPUs, and by doing that, we minimize the energy consumption. So this is an edge application. This needs to happen in real time, and you get all the benefits from the edge. So it's fast, it's local, and it's intelligent.
That's great. Michalis, do you have any examples where you've
There are hundreds of examples, but we need 2 more days to exhaust the list. So
you got 15 minutes.
I'll just pick, let's say, a couple of these that
You can go.
I find quite relevant also to our country. I will pick up some, let's say, examples from the public order, for example, for, let's say, because we need, let's say, to feel safe. Okay, so how do you feel safe? So still in Greece we have a debate whether we need cameras or no. But if we had cameras everywhere, in a consensus that cameras will protect us. Cameras can be highly intelligent and can process data locally, and they can then prevent accidents. For example, we can see cameras located in traffic lights that can be connected to a kind of alarming system that in case that you can predict that someone is upset by it or is going, let's say, to crash, it can start, let's say, making noises and things that can, let's say, prevent the accidents. We can have traffic optimization, for example. In Athens, we have quite, let's say, lots of chaotic situations during the day in specific streets, but then we have unnecessary waiting in the traffic light. So you can have such a system, and these are real examples that have already been implemented, practical examples that could be implemented today. You can optimize so that you reduce not only the cost of, let's say, transportation, but also you avoid, let's say, the psychiatrists after such long waiting to the streets. Also, we have quite intelligent systems that can be applied in kind of disaster management situations. So situational management, like in floods, earthquakes, wildfires. All these are real examples that can be implemented today, and they are getting better and better. And all this can be implemented always at the edge. You don't need, let's say, to wait for something to be deployed in a public cloud model. It can be a combination of public cloud and local resources that can give the efficient, let's say, outcome you need in order to face specific problems.
Do you think 5G or even 6G needs to be an enabler for that, for localized compute, whether it's at traffic lights or
5G or 6G, which is coming, is just, let's say, for me, an extension of what you can do on IP6 or IP7, let's say, local Wi-Fi network. So we see that there is this convergence, and the ideal situation is that the signal does not stop anywhere. So you start from the data center, whether it is, let's say, a co-location or a public cloud provider, and you can transmit the signal to the last point. And of course, the more the G is, R, the better for all of us. So G matters.
Great. Okay, so sort of moving on. Let's look at some of the commercials as well. So, Alexandros, there's multi-billion-dollar deployments announced, on a very regular basis, especially with a focus around hyperscale data centers globally. How can investment in smaller infrastructure assets compete for attention?
I'll start with a simple statement that money goes, or investment goes, where investors think they're going to make money. So if there are business cases, and it seems there are business cases, more and more every day, and as I talked earlier, we will see increasing pace in relevant, such relevant applications, we will see more need that needs to be covered, so more investment will continue flowing. And it doesn't seem that currently lack of money is an impeding factor. There aren't infinite resources on anything, that's for sure. But if take as an example what we discussed earlier, we saw what was the number one thing to delay data center, for example, is lack of power, difficulties in permitting, not enough submarine cables to take the traffic. Satellite industry, still not catching up, and they need even more investment. So at the end of the day, there are multiple factors. I would say that the needs will be covered, but we also need to realize that not all problems have been solved yet. Not all needs are out in the open. We are in a very transitional phase of our evolution of using IT technology. And this exponential change that we're currently in, nobody, I don't understand completely how it will evolve and how it will affect all these models. So what we need to do, because we cannot just stop waiting and wait, is understand what we have, run as the very good examples that were said. We also have our own, and understand the technology more, make it more useful, adjust the models, and then it will be coming together as it always has. And there will be a cat and dog game always, because always there will be a vision that is in front of what we can do today, but this is a good thing. If we are satisfied, we are done. We will never be satisfied, it's not a problem. The problem is, are we focused on chasing the right targets? From usability, sustainability, of course, it will never stop being important. And again, keeping our eyes on what this is doing to our societies, to our users, to our economies.
Sorry, Chris.
Yeah, so I think this looks like a small versus big problem. Okay, so it's a very old problem. It looks like how can you stand out in a room full of elephants? This saying. You have to bring in the circus. So you have to make noise. And what's the noise that you can do at the edge is the benefits that you get. So instead of talking about large scale, you need to talk about efficiency. You need to talk how much easier it is even to build an edge data center, and it's something instead of a gross and super duper centralized data center. So you need to talk about these things. You need to talk about the value, the benefit that you get per euro that you spend on an edge data center versus a centralized one. And at the end of the day, you need to talk about the use cases that you're bringing. That's the real value. So I think that the question needs to shift from small versus big to smart versus slow. Slow the latency. Okay, smart intelligence at the edge. So I like to think it that way.
Okay, thank you.
Same question?
Sure. If you have an opinion, yes, please.
No. I think that the best way, let's say, to just compliment my colleagues here is to think what we did yesterday as a company. Hewlett-Packard Enterprise yesterday signed a big agreement with the Greek government on Daedalus. Daedalus is the basis of the AI factories in Greece, called Pharos, which is part of the 7 AI factories in Europe. So why do we need a local factory? There should be a good reason. We need, let's say, such a factory, we need such an option, because by definition we need degrees of freedom, and we need, let's say, alternative ways of controlling the future. And in Europe, being in this situation, I think that it's good to have some kind of, let's say, control and data sovereignty, let's say, tools in hand. I think that this is one dimension. A second dimension when it comes to why we need this kind of analysis because if you are close to the data, you can be more precise and you can, let's say, get more optimized. Not everything can be managed and achieved simply by using something that is far away. So I believe that by definition, cost optimization and precision, when it comes to critical applications, is something that can be addressed better. So I don't believe that any investor would say no if you had these, let's say, two good reasons in mind to invest in a decentralized, let's say, option.
Great, thank you for that. Okay, a pretty broad question, but Carlos, sticking with you here, environmental challenges and impacts on sort of AI edge.
Yeah, I think it was also very in a good detail discussed in the previous panel as well. Yes, AI applications are by definition energy hungry, so we need infrastructures, we need let's say options that can better manage the energy. I will take again Daedalus as an example because this will be built in cutting-edge technology using a new technology that is called direct liquid cooling, DLC. So you cannot, you will not even hear any noise when you're sitting next to this kind of machine. So the whole cooling of the system will be taking place by using water that will be, let's say, somewhere next to the, some chillers will be next to the machine, so you don't need at least, let's say, the power to cool, which is the biggest amount when it comes to infrastructure. I think that this kind of technologies within the systems, within the infrastructure, in combination with sophisticated techniques inside the data center, which is my friend Alexander's obligation to define, is what needs to be taken into consideration, and it should be a must for any investment around the edge AI.
Alessandro, Digital Realty doing anything
Yes. Yes, but I'll continue a little if I may. I'll say something, and I don't want to be provocative, but I will say that energy's single purpose is to be consumed. So we shouldn't be demonizing the consumption of energy as long as it is used to do good things or to create, let's say, to avoid overspending elsewhere. And there are many examples where the use of AI is producing results by using power, of course, and equipment and knowledge and everything. So we do not have to drive. We do not have to lose time in queues. We get productivity gains which enable further enhancement of our both personal and business product on this earth. So at the end, this balance needs to be understood on its application. So it's not the main criterion, the main reason to, we shouldn't be after reducing energy, but using it for a good cause. So understanding what we use it for.
And a good price.
Yeah, of course. But as was said many times, and it's not only a Greek phenomenon, but in Greece it's very, very evident. We are overproducing energy this week. Now, we need to distribute it better. It's a very big problem. We need, the new solar technologies that are coming into line. These problems will be solved, are being solved. So at the end, we should focus on what we do with energy. How AI can be used for, the proper causes. And forget too much about the marketing. And I'm not saying, sustainability, health and safety are our three main purposes that are in everything we do. But let's not forget that we serve the customers. Now, there was a question that I forgot.
I forgot this one. I think we're actually running out of time. So what I'd like to do is maybe open it up to the audience if they have any questions for the panelists before any final comments. Question over there.
Yes, thank you. You mentioned use cases for the edge and use cases for the center. But isn't it true that this is more about systemic thinking, really, for example, solving for mobility? And then that includes applications around parking tickets, zoning laws, or traffic optimization. Who should bring this systemic thinking to people like yourselves? Or are you going to bring it to the market?
Question to everybody, I guess. Huh? Yeah, I think that when there is a good idea, we just need two parties. One that will transmit, one that will receive. So we are the ones transmitting this kind of ideas, and we have many places to do so. I think that during the last years, what is happening in Greece, for example, gives us the opportunity to address this kind of good ideas to the right, let's say, to the right ears, either within the government or within the local authorities. And we see many of these ideas taking, let's say, good probabilities to be implemented. We have not seen many yet, to be honest, but I think that we have mature conditions to do so. And if we talk about, for example, smart cities, real smart cities, where everything is connected and everything can, let's say, take advantage of the insights of data created within, let's say, a defined area, I think that the future is quite, let's say, close.
Okay, I think we've just run out of time. I'd like to thank our panelists, especially Chris, with the analogies on the circus and and the house party. Wonderful. Thank you very much. If you have more questions, please grab the panelists.